Can you see my screen?
Yes, sir.
Okay, thank you. Okay, so what we were doing last time, so we are doing this practice assignment, last week practice assignment. So let's finish this today. So we are doing this third problem. First and second we have already done, and third, first and second part we already done. So let me again write this problem, then we will try to solve it and get intuition from this and develop the theory of cyclotomic polynomial. Like last time someone asking me that this thing is not done in class, so today I will do this thing also, cyclotomic polynomial and cyclotomic extension, degree of cyclotomic extension. If I use that theorem that cyclotomic extension have degree phi n for so then it is almost obvious this question, but I don't want to use that. I will prove that, but first I will do this question, then I will do that theory, whatever that cyclotomic extension theory. So let's do this question by basic theory, whatever we know. So choose all correct statement, and this is the question. Choose all correct statement. Degree of splitting of x to the power 4 minus 1 is 2. Can you recall how I proved this? Is this true or not? Last time I did this. Someone can respond. Utkumar, do you recall last time I proved this? This is true or not? Am I audible to you? Mayank, am I audible to you?
Yes, sir.
Okay. So have you attended last session?
No, sir, I didn't attend the last session.
Okay, fine. So how we will prove this thing? X to the power 4 minus 1, this degree of this splitting field is 2. So let's see. This x to the power 4 minus 1, you can use a square minus b square formula. So this you can write x square ka whole square minus 1 square. So this is x square minus 1, x square plus 1, right? So now the degree of splitting field of x to the power 4 minus 1. What is the splitting field of x to the power 4 minus 1 basically? Where smallest field, where this can be written as a product of linear factor, right? This is the basically intuitive definition. This is the definition of splitting field basically. So now if you are thinking to write this polynomial x to the power 4 minus 1 as a product of linear factor, let's see. So how you can write? So x square minus 1, x square plus 1. This x square minus 1 you can further reduce x plus 1, x minus 1, x square plus 1. Now see, these factors are already available over qx. So you nothing need to add anything as for this one. So you need only to add roots of this one, right? This is the only irreducible factor. So the splitting for this is the splitting field of x to the power 4 minus 1. Your field is given over q. Okay. So the splitting field of this polynomial x to the power 4 minus 1 is splitting. So splitting field of x to the power 4 minus 1 is splitting field of x square plus 1. So, but x square plus 1 is irreducible polynomial. So like x, its root are plus, what is its root? Plus minus iota, right? Sorry, x square is equals to minus 1, so its root are plus minus iota, correct? So its root are plus minus iota. So if you add iota, then minus iota is automatically there. So iota, it is a 2-degree extension. So q over q, this extension q iota is degree 2, and q iota is splitting field of x to the power 4 plus 1. So we are done. So this is true statement. Right. So then next question is the splitting field of degree of splitting field of x to the power 4 minus 1 over q is 4. So here in first part I proved that this is degree 2, so it cannot be 4. So this option will be automatically false, right? The next question, next part in this is the degree of is over q is 4. So see how you can write this x to the power 8 minus 1, x to the power 4 minus 1, x to the power 4 plus 1, right? Now see this x to the power 4 minus 1 you can further reduce, x square minus 1, x square plus 1, x power 4 plus 1. This you can further reduce, x plus 1, x minus 1, x square plus 1, x to the power 4 plus 1. Now see, these first two factors are already present over qx. So for adding these roots, you need no need to add anything over q. So these roots and this x square plus 1 roots and x to the power 4 plus 1 roots you need to add. So my claim is that the splitting field of x to the power 4 plus 1 and x to the power 8 minus 1 is same. So means that if I compute like the splitting field for x to the power 4 plus 1, then the roots of these are x to the power 8 minus 1 are already there. So that is the my claim, right? So x to the first claim is that x to the this thing I done in last class, so I am just summarizing this thing, that's why I'm going quickly. X to the power 4 plus 1 is irreducible. This thing I done in last class. Okay, so if this thing x to the power 4 plus 1 is irreducible, then qx over x to the power 4 plus 1, this is a field, and it's suppose this name this as a k, and k over q is degree 4 extension, right? So since this is a 4-degree minimum, 4-degree polynomial, and this is minimal irreducible. So yeah, this thing. So this is a 4-degree extension, and x to the power 4 plus 1 is irreducible. Now my claim is that at the root of the, we claimed this time in last lecture that x to the root of x square plus 1 is already in k. This thing I proved in last lecture, means its root are plus minus iota and both were present in k. This I proved in last lecture. So we done this. So K is splitting field of x to the power 4 plus 1. This implies, so K is a splitting this thing, and I'm going quickly over this because this thing I done in last lecture. I'm just summarizing because there are some new participants who could not join last lecture, who did not join last lecture. So I'm just summarizing this for them. So K is a splitting field for x to the power 8 plus 1. So x to the power 4 plus 1 as well x to the power 8 minus 1. So this implies K over Q is degree 4 extension. So this statement is true. This statement is true. So now the next part, it is saying that degree of splitting field of x to the power 8 minus over q is 8. So if degree of splitting field of x to the power, I prove in C that degree of splitting field of x to the power 8 minus 1 over q is 4, so it cannot be 8, right? So it is false. So try to observe a pattern, right? In first part, I proved that degree of splitting field of x to the power 4 minus 1 over q is 2. I should write here over q is 2. And in Cth part, I proved that the degree of splitting field of x to the power 8 minus 1 over q is 4. You know Euler-Torsion function, right? So Euler-Torsion function, try to see this degree, fourth degree, this fourth degree cyclotomic polynomial. So if n is equals to 4, then phi of 4 means Euler-Torsion function of 4 is true, right? So the degree of splitting field of this nth cyclotomic polynomial is phi n basically. I want to give you that observation from these examples, right? X to the power 4 minus 1 splitting field has degree 2 and phi 4 is also 2. X to the power 8 minus 1, x to the power 8 minus 1 splitting field has degree 4 and phi of 8 is also 4. You know how to compute phi n, right? If you don't know, let me know, because I can explain you how to know phi, how to compute phi n. If you don't know, please you can ask. Otherwise, I will.
Sir, how to compute, sir? What?
Phi n, Euler-Torsion function. You know that?
No, sir. Please recapitulate it.
Okay, fine. Okay. Euler-Torsion function. How to compute phi n for n belongs to z plus. So anyone of you know this? Let me ask first. So
No, sir.
okay, Mayank also know, don't know. And what is Baliram Kushwaha, whatever. So you know this or not?
Yes, sir.
So what is the formula of Euler? How to compute Euler-Torsion function?
Euler, first factorize.
Okay. Let me factorize. So write n as a product of p1 to the power alpha 1, p2 to the power alpha 2, so on, pr to the power alpha. This you can always do for any number. You can write as a its prime decomposition, right? So this is the thing where pi are primes. So then what you will do? How you will compute? What is formula of
1 minus
1 minus
alpha 1
alpha 1
into
into
1 minus alpha 2.
1 minus alpha 2. Okay, this is not correct, right? So
Yes.
if this is correct, so let me give you an example. Take n is equals to 5. Take n is equals to 5. Okay. So when what is okay, it is already prime, right? So it is prime. So what is this? Alpha 1 is 1 basically. 1 minus 1 is 0. That means phi 5 is 0 according to your formula. According to your formula. To your formula, right? But you can see phi n denote the number of integer greater than equals to 1 or n less than strictly less than n, which are co-prime to n basically. But there are but phi n should be 4, right? Phi n should be 4. Basically, these numbers are 1, 2, 3, 4, or are relatively co-prime to 4, relatively co-prime to 5. So you can see your formula is incorrect, whatever your name, Balira. So this formula is incorrect. So anyone else? Muthukumar, you know formula of Euler torsion function? Okay. So let me explain how to compute. So phi n is equals to n dot 1 minus 1 over p1, 1 minus 1 over p2, 1 minus 1 over p1. So this is the form PR, whatever the decomposition. I write PR, right? I write PR, yeah. So phi n basically denotes number of positive integer less than n and co-prime to n basically. So like phi 5 is 4, phi 3 is 2, phi 4 is basically 1 and 3, so 2. So this is the way how you will compute, and the formula is you can write this is these PIs are the primes coming in the prime decomposition of this n. So basically phi n is n dot 1 minus 1 over p n dot 1 minus 1 over p2. So let me ask you how to compute, then it will be clear. So take n is equals to 20. So tell me a prime decomposition of 20. So how you can write 20? Tell me. You should unmute yourself, otherwise you will not understand.
2 into 2 into 5.
2 square 5.
Yeah, 5. So how you will apply this formula to this one, 520? So it should be 20 dot 1 minus 1 over 2 dot 1 minus 1 over 5, right? So what is this? 20 dot 1 by 2 dot 4 by 5. So this is what? 5 to the 10, 10 to the 20, 4 to the 8, right? This is 8. So let's compute the number. So it should be, let me verify how you will verify this is correct or not. So verify that this is correct. So how you will verify? Number of positive integer less than and equals to less than 20 and co-prime to 20. What are they? So integers, positive integers less than 20 and co-prime to 20. What are they? Let's list them. 1, 3.
So 2 also?
No, 2
Achha,
is not
okay,
co-prime to 20, right?
Okay, sir.
2 and 20 have GCD 2, right?
Yes, sir. 1, 3, 5, 7, 11, 13,
5
17,
divides
19.
20. 5 and 20 GCD is 5.
Okay.
7.
11.
9 also, right?
9 also. But 9 is not prime, na? Achha, co-prime.
Yeah. 9. 11. 13.
17, 19.
17. 19. So these are 8 number, Aish. 1, 2, 3, 4, 5, 6, 7, 8. So this is the thing, right? We verify this is correct. Agreed or not?
Yes, sir.
Yeah. So this is the thing. So in this first part, I proved that this degree of splitting field for x to the power 4 minus 1 over q is 2. And in third part, I proved that degree of splitting field of x to the power 8 minus 1 over q is 4. You can compute phi 8 and phi 4. Phi 4 is 2 and phi 8 is 4. So I just want to give you the observation. I will prove this in today's lecture, but I just want to give you intuition. This is matching with phi 4, phi 8 basically. The degree of splitting field of nth degree cyclotomic polynomial is basically phi, and I want to give you this idea of this theorem basically. So let's do next part of this one. The next part is that degree of splitting field of x to the power 6 minus 1 over q is 2. The degree of splitting field of -1 over q. Yeah, but you can check by formula, right? By according to what according to that theorem, what it should be? Phi 6. What is phi 6? Phi 6 is 6
2,
dot
sir.
1 minus 1 by 3 dot 1 minus 1 by 2, right? So what it is?
2,
Six.
sir.
Yeah. So 2 by 3, 1 by 2. So it should be 2, right? But you should check by explicit computation, because this, yeah, it's the option should be correct because you verify this by this computation. But you should check by explicit construction. However, I'm the way I did first 4 option, you should do in that way, right? So how you will do? X to the power 6 minus 1, you can write as x cube minus 1, x cube plus 1, right? So x cube minus 1, how you can write this? X minus 1, x square plus x plus 1, and this is x cube plus 1, right? Yeah. So you should claim that -1 is already in Q, so this is not, no need to worry about that. So you should claim that this is the polynomial, means you should claim that k modulo qx mod x square plus x plus 1, x square plus x plus 1 is splitting field of x square plus x plus 1 is splitting field of x to the power 6 minus 1. So basically you need to show that x cube plus 1 all roots comes in this field. Basically you need to show that fact. But you can do this because what are the root of x square plus x plus 1? Basically what are its roots? This is irreducible polynomial over here. You can check because its root are not here. A 2 degree or a 2 degree polynomial is irreducible if its root are in the field, right? Is irreducible if its roots are not in the field, right? So its root are not in the field. What are its root? You can use Sridharacharya formula, whatever is that. So minus b, what is that? Minus b plus minus square root of b square. What is b square? 1 minus 4ac divided by 2 of a. So what is this? Minus 1 plus minus iota root 3 by 2, right? So these are the two roots of this polynomial. So these are not in the field. That's why this polynomial is irreducible. And since q is a field, so qx is a PID, and the polynomial generated ideal generated by irreducible polynomial will be maximal ideal. So qx, so x square plus ideal generated by x square plus x plus 1 is a maximal ideal. So qx quotiented by x square plus x plus 1 will be a field, basically. So k is a field, and so it's so the roots are this thing. So you should claim that root of this polynomial x cube plus 1 are already there. So what are the root of x cube plus 1? How you will compute roots of x cube plus 1? So what are its root? X cube equals to -1, right? So okay, what is -1? Tell me what is -1? When cos value is -1?
Sir, at
180 degree.
At 180. 180 is pi, basically, right?
five.
Yes, sir.
Yeah. So how you can write this? E to the power I pi, right? Agreed or
Yes,
not?
sir. Yes, sir.
Yeah. I pi basically cos pi plus I sin pi, but cos pi is -1 and sin pi is 0, right? You know basically this formula, right? E to the power I theta is cos theta plus I sin theta.
Yes, sir.
Yeah.
Yes, sir.
So,
Euler's form.
yeah. So by that way you can open this. This is, so x cube is equals to e to the power I pi. So this implies x is equals to e to the power I pi by I k pi. You can write this I k pi. I k pi. You can't write this I k pi, but you can modify this. How you will modify? Let me correct this. ik pi means I just want this thing pi, 3 pi, 5 pi basically. So how will I will write this? How I will write this? I basically want pi, 3 pi, this kind of multiples, right? Pi, 3 pi, 5 pi, this thing I want. So how I will write this in a general way? E to the power iota outside 2n minus 1, 2n minus 1 pi, right? This is the correct way to write. Agreed or not? In general way, how you can write it? E to the power I pi. This is basically one value, but what is general value? For n belongs to natural number. This is the way how you can write, right? For n equals to 1, this is pi. For n equals to 2, it is 3 pi. For n equals to 3, it is 5 pi. Basically, this is the way to write. Agreed or not?
Yes, sir.
Yeah. So this is e to the power. So what is the? Let me write this line again. So what is this? So x is equals to e to the power iota 2n minus 1 pi by 3. Now see, n is equals to 0, 1, 2. If you put n equals to 3, then what is this? N equals to 3, 3 to the 6, 6 minus 1, 5. E to the power 5 iota pi by 3. You can check that this is okay. Check that this is same as this thing. E to the when you put n equals to 0. Okay, let me check these things. So when you put n equals to 1, what is the value? When you put n equals to 0, what is the value? E to the power minus I pi, right?
Yes, sir.
So what is u to the power minus I pi? Cos minus pi plus I sin minus pi, right?
Minus of cos pi plus I sin pi.
Cos minus theta is equals to cos theta, right?
Yes, yes, sir. Okay.
Yeah. So cos pi plus I minus I sin pi. So basically,
Yes.
so what is the at n is equals to 0? What is the value? Cos pi is minus 1 plus I sin pi minus I sin pi. Basically, that is 0. So what are roots? X is equals to minus 1. At n is equals to 1, what is the value? At n is equals to 1, what is the value? You should tell me this. These are the computations. I just want to show you the roots of this polynomial, and you are
And
not.
n is equal to 0, x is equal to minus I pi by 3. Minus I pi by 3. So this is not correct.
Oh yeah, agreed. Oh, denominator also 3. Agreed. Sorry. So n is equals to minus n is equals to 0. Okay, correct this computation, whatever this is. So x is equals to e to the power minus I pi by 3. So what is this? Cos pi by 3 minus iota sin pi by 3. So what is cos pi by 3? What is cos pi by 3?
Half.
Half. And sin pi by 3?
Root 3 by 2.
Root 3 by 2. Similarly, you can check other things. So when n is equals to 1, n is equals to 1, what is this? 2n minus 1. So n is equals to 1, what is this? X is equals to e to the power I pi by 3, right? So what is this? Cos pi by 3 plus I sin pi by 3. Basically, that will be 1 by 2 plus iota root 3 by 2. At n is equals to 2, what is this? What is this? 2n minus 1. So basically 2 to the 4 minus 1, 3. So e to the power I pi, right? So what is this? Cos pi plus I sin pi. So cos pi is 0. Sorry, cos pi is minus 1 and sin pi is 0. So this is minus 1.
Minus 1.
Yeah. So these are the three roots. When you put check, just let me give you n is equals to 3. What will be the root? 2n minus 1. So 3 to the 6 minus 1, 5. So x is equals to e I pi 5 by 3. So what is this? Cos 5 pi by 3 plus I sin 5 pi by 3. So what is this? How you can write this? Cos 2 pi minus pi by 3 plus I sine 2 pi minus pi by 3. So what is cos 2 pi minus theta? Tell me.
Cost
Yeah, cos pi by 3 plus what is sine 2 pi minus theta?
sin pi by 3.
Minus sine pi by 3. Cos 2 pi
minus
minus
sin
theta.
pi by 3.
Yeah. So this value you get already above, right? So this is repetition starts. Yeah, this is the value you already got. So repetition start हो गया फिर से देखो. So this, that's why I am saying you need only n equals to 0, 1, 2. Now the value will be start repeating from here. So these are the three roots of this polynomial. So minus 1 is already in Q. You only need to show that this is thing. Iota and root 3 by 2, root 3 are in Q. You only need to check this thing. But you can do this easily, right? This is not a hard computation. How this is already in K, you need to show that iota and root 3. But by arranging this terms, like its root are minus 1 plus, since minus 1 plus minus iota root 3 by 2 in Q, so all its addition multiplication will be in Q, and you can check like I did in last time. So how you will do? Let me do it. So since minus 1 plus minus iota root 3 by 2 belongs to K. So what is the meaning of this? This means minus 1 plus iota root 3 minus 1 plus iota root 3 and minus 1 okay, minus 1 plus, so that means minus 1 plus iota root 3 belongs to K. Since 1 belongs to K, this implies minus 1 plus 1 plus iota root 3 belongs to K. Okay, this implies iota root 3 belongs to K, right? Okay, iota root 3 belongs to K. You need to show iota belongs to K and root 3 belongs to K. How you will show? You only need to show this thing, right? For this one, for these root belongs to there, you only need to show iota belongs to K and root 3 belongs to K. How you will show this? So see, you don't need to show this iota and root 3 in K, but iota root 3 is in K, you already proved. So that's why this root is already there, right? Iota root 3 is there, so 1 by 2 already there, iota root 3 is there, and 1 by 2 also there. So 1 by 2 minus iota root 3 by 2 already there in K, and similarly 1 by 2 plus iota root 3 by 2 is already there, and minus 1 is in Q, so hence in K. So all the roots are there. So this implies 1 by 2, whatever the root, iota root 3 by 2 is already there, and 1 by 2 plus iota root 3 by 2 in K, and minus 1 belongs to Q, implies minus 1 belongs to K. So K is splitting field for x to the power 6 minus 1. But what is x to the, so what is K? K is basically this field, right? I write above qx mod x square plus x plus 1. So this polynomial I already check above, this one is irreducible since it is 2-degree polynomial, its root are not there. So this is the irreducible polynomial. So and minimal polynomial for, and so ideal generated by it will be maximal ideal. So it will be filled. So degree of extension will be this degree of this polynomial. Degree of extension over Q is 2. So this is a 2-degree extension, right? I proved this is a 2-degree extension, and above by formula I already showed you that this is a 2-degree extension. So this is both way verification. So this is the true. Where is pen? Yeah. So any doubt in this computation? This is just a computation. I just want to show you how to compute this, how to calculate. Any doubt?
The degree of the splitting field is pi of n, valid only for polynomials of the type x power n minus 1.
Yeah, this is cyclotomic polynomial theory. I will do this thing, but let me complete this question. Today I will do this theory. I'm just giving you idea basically. for this these are specific kind of polynomial. When you will read Galois theory, this plays some special role there, special role there also in Galois theory. But that will be not done in this course. But whenever you get an opportunity to use this, so this will be good for you. But I will do cyclotomic polynomial theory today, cyclotomic extension and cyclotomic polynomial this thing today. So the next part for this is the degree of splitting field of x to the power 6 minus 1 over q. The degree of splitting field of x to the power 6 minus 1 over q is 4. So this is false option because I already proved in part E basically degree of extension is 2, so it cannot be 4. So let's come to, so what you want now? Do you want to solve problem of previous year assignments or want to do the theory of cyclotomic polynomials? So what you want? Tell me. I can do both things, right? I can do as a previous year assignments as well, because this year practice assignment I already done, so I can do previous years. So what you want? Muthu Kumar, what do you want?
सर कुछ प्रॉब्लम ही कर दो, एक दो सर, फर्स्ट टू थ्री प्रॉब्लम देन थ्योरी.
Okay, so fine. Okay, we can do previous year assignments on this same topic. So let me open that. Give me a second. PTL course. Okay. Wait a second. Okay. Okay. So this is the first. Yeah.
Sir, please explain why C over Q is infinite. matlab.
Infinite field extension.
Yes, sir. Why?
Okay. So tell me. Okay. What is the degree of extension of this field? Okay. Q root 2, root 3, root 5, root 7, root 11, root 13, so on, so on, so on. So tell me degree of extension of this field. And this field, it sits inside.
Yes.
This is contained inside. So let me name this field Q. What is degree of extension K over Q?
Infinite.
Infinite. So if this degree of field extension is infinite, that will be obviously infinite, right? It sits inside C basically.
Okay.
Agreed or not?
Okay. Okay. I agree.
Okay. Any other doubt? Okay. Okay. So let's do previous year assignments, whatever Ravi Shankar says. So the question is, choose all correct statements. Every subfield of C contains Q. So first question, choose all statements. First one is, every subfield of C contains Q. So yeah, every subfield of C contains Q. So is this
true, no? True.
How you will prove this?
Q is the minimum unknown.
Okay, how you will tell me? Tell me how you will.
Every field is extension of Q. मतलब
No.
मतलब in every infinite field is extension of Q.
What about this? Its closer. Z mod PZ closer. Its closer. Its closure will be infinite field. So how you will claim? But it is not subfield of C. So it's not correct statement, right? Whatever you are saying. You can prove that any algebraic closure is infinite basically. The idea is that you need to prove that infinitely many irreducible polynomial over this field, and that is not a big deal to prove basically. How you prove that infinitely many primes are there? So that idea is same to this, right? Suppose there are finitely many, then you produce a new one which is not in this list. So that way you argue that there are infinitely many primes, right? I hope that in 12th class or 10th class basically you done these proofs. There are infinitely many primes or this kind of idea. So similar proof for here. You can prove that there are infinitely many irreducible polynomial over any field, polynomial ring over any field. So by that argument, you can prove that its algebraic closure is infinite basically. So if its algebraic closure is infinite, but it is not subfield of C, basically it is of characteristic P and C is of characteristic 0. So that way you can argue that whatever you are saying is not correct. So tell me another argument.
Sir, C is algebraic closed.
Yeah.
So
Don't go to algebraic close. From there you cannot attempt this question. Algebraic close पे है तो क्या है? Algebraic close तो तुम ZP का भी बना सकते हो, किसी का भी बना सकते हो algebraic closure. Basically algebraic closure मतलब क्या है? वहां के सारे एलिमेंट के लिए एक मिनिमल पॉलिनोमियल मिल रहा है बेसिकली उसके ऊपर. जो algebraic closure कहने का मतलब क्या है? सारे के सारे एलिमेंट algebraic हैं बेसिकली, राइट? So use the characteristic of C and characteristic of Q, both are 0. So how you will argue? Characteristic को define कैसे करते हो? How you define characteristic? Kernel of what map?
Z to R any field.
हाँ. Here what is your field here? C, right?
Yes,
Agreed
sir.
or not? Yeah.
Yeah.
So C का characteristic क्या है? पता है ना? What is characteristic of C?
0.
Yeah. C का characteristic 0 है. तो Z से C and characteristic 0 means kernel of phi is 0, right?
Yes, sir.
Kernel phi is 0. That means this is injective ring homomorphism, right? This is 1 1. Kernel अगर 0 है तो yeah. So this is injective. So Z sits inside C, right?
Yeah.
So if Z is inside C, so this implies where is this? This implies Q sits inside C. How? Tell me how.
Q is subset of C.
Okay. Okay. So let me write it in another way. It will create a doubt to you. So if L is any subfield of C, if L is any subfield of C, so what you can do? So let's write it clearly. Otherwise, it will create some doubts in your mind. Characteristic. Yeah. Okay. Yeah. So Z to L. So how you will define ring homomorphism? 1 goes to 1 and 2 goes to 1 plus 1, basically 2 goes to 2. L is contained inside C, right? L is subfield of C. So now see, what is the kernel of this phi? Kernel of phi. What is kernel phi? What can be kernel phi? Basically, tell me.
What is map?
Map you can from Z to any ring. There is a unique ring homomorphism, right? We proved this. So this is that unique one ring homomorphism. So what can be its possible kernel?
Kernel is NZ type. NZ.
Okay. Its kernel can be NZ type, but what is N basically? If its kernel is N non-zero, so what is the meaning? since L is contained inside C, so L from L to C there is a injective ring homomorphism, and Z to L there is its kernel is NZ. So Z to C we got a ring homomorphism which kernel is NZ. Agreed or not?
Yeah.
So that is contradiction to fact that, right? Z to C there is only one ring homomorphism whose kernel is 0 basically.
Yes.
So that means kernel phi is 0, right?
Yeah.
So kernel phi should be 0 basically. So now you are done. If you prove that kernel phi is 0, then what you need to do? That means,
But I don't know what the relation between this question and this.
yeah, this is the relation, right? Z to L there is a injective ring homomorphism you got, right?
Yeah.
So this implies Q to L there is a injective ring homomorphism. How?
Oh, yes. मतलब composition of function. Yeah.
No, not any composition. You should think. This is just a,
मतलब Z to Q is kernel phi is 0 and Q to
oh, you are not getting right. Just try to think. So if any A by B belongs to Q, right? If
Yeah.
any A by B belongs to Q, right?
yeah.
You need to show that this A by B is in also L. To show A by B is also in L. So how you will prove? Since A belongs to and B is non-zero here, A belongs to Z, this implies A belongs to L, and B belongs to Z, this implies B belongs to L, and B is non-zero. So if some non-zero element in this field, then its inverse is also in field, right? That means
Yeah.
1 by B is equals to B inverse is also in L. So if A is in L and B inverse is 1 by B is in L, this implies A by B is also in L, right?
Yeah.
Yeah. So we are done. A by B is in Q, then A by B is also in L. So Q sits inside L. Agreed or not?
Yes. Yes. I agreed.
So I proved that if any subfield of L, I take any L subfield L of C, then I prove that Q sits inside that subfield. Agreed or not? Any doubt?
Yeah. Yeah.
Anyone else? Is this clear or not?
This is clear.
Clear, sir.
Yeah.
Yes,
So I
sir.
already
If
done this thing in previous assignment, I guess.
so, sir, here
Excuse-
L becomes subset of Q.
Excuse me,
Yeah, tell me.
1 belongs to L.
Yeah,
So 1 plus 1 n number of times is in L.
agreed.
So n belongs to L.
Agreed. So that is also idea. Every integer belongs to L. So that's the same way.
Yes.
Basically, kernel is
If-
0.
If it is non-zero, then 1 by n is also in L.
But you need to prove that it is non-zero, right? That's where you need to show that kernel is basically 0. Agreed or not?
Because that is zero only if the characteristic is some.
So this is same thing, right? Kernel proving 0 is basically same thing as characteristic proving 0, right? Characteristic is defined in this way. I hope you agree. If not, you can ask.
Sir, here L is contained in Q.
L is contained in Q. No. Q is contained in Li proof.
Okay, sir. So, sir, A by B element we have initially it belongs to which, L or Q?
In
A
Q.
by B. Q,
A by
okay.
B is in Q. I prove that A by B is also in.
Okay, sir. So Q is contained in L.
Yeah. The second question, second part of this. Every subfield, the degree of root n over Q is 2 for every positive n integer n. Degree of root n over Q is 2 for every positive integer n. Is this true or not? I hope I done this
Not
question
true.
in.
Not true. Not true.
Not false.
So what is the example for that?
4.
Okay. N is equals to 4. You are done, right? Root 4 is equals to 2. And so Yeah, x minus 2 is the polynomial for this. So degree of 10 over q is 2. This is degree 1 basically. So this is false. So what is third one?
सर ये समझे नहीं सर, this x minus 2.
Okay. So degree of root n over q is 2 for every positive integer n. What is this meaning? Degree of root n. What you mean by degree of root n? What do you mean by degree of root n over q? Tell me.
Sir, the roots are like, मतलब 2 square equals to
What
4.
is the meaning of degree of an element alpha belongs to k?
Degree of its irreducible polynomial.
हाँ, number
Degree
of
of its
time.
minimal polynomial, right?
Yes sir.
Degree of minimal polynomial, so such that degree of minimal polynomial, suppose f is a minimal polynomial, which for which f is a minimal polynomial such that root n is a root of f, then degree of f is a degree of root n basically. This is the way how you define. So degree of root n over q is 2 basically. This is saying for every positive integer n. Suppose you choose n is equals to 3. N is equals to 3. Then what is the degree of root 3? What is degree of root 3? What is degree of root 3? What is the minimal polynomial for root 3?
X square minus 3.
Agreed. X square minus 3. So this is the minimal polynomial since root 3 is not there. But if I choose n equals to 4, then root 4 is 2. Basically, this is the polynomial in qx. 2 is already there. So degree is 1 basically for this one. Root 4. The degree is 1. So for every positive integer, degree is not 2. So that's why this statement is false. I hope I done this question in previous assignment. Maybe these are same question as I'm doing in. So basically some question can be same in previous year assignment or in this year assignment. I remember I done these questions already. So the next question is the degree of root 2 plus root 3 over q is 2. Is this true or not? Now you already read the field theory. This should be some obvious question for you, right? You already should remember.
Not true.
Not true. Why?
The minimum polynomial is 4. So,
How you will claim that is minimal?
we can construct one polynomial from.
How you will first? How you will give me a polynomial of degree 4 for this? You are claiming that, right?
Yes, sir.
So how you will claim? How you first give me a polynomial of degree 4 for which root 2 plus root 3 is a root of that polynomial.
If it is root, then alpha is equal to say root 2 plus root 3.
Okay, say
Mhm.
x is equals to root 2 plus root 3. Then x minus root 2 should be root 3.
Then squaring.
Yeah. Give me a second. This is not responding. Yeah. Okay. So then you can square this thing. This is x square plus 2 minus 2 root 2x is equals to 3. So what you can do, x square plus 2 minus 3 minus 1 का whole square is equals to 2 root 2 x square. So x to the power 4 plus 1 minus 2x square is equals to 4 or 2 x square. So what you get? X to the power 4 plus minus 4 to the 8 minus 2 10 x square plus 1 is equals to 0. This is the 4th degree polynomial. Now you are claiming this is the minimal one. How you will claim this thing?
Can we use Eisenstein criterion?
How you will use Eisenstein criteria?
We will take a prime and then
What prime you need? What is the Eisenstein criteria? First tell me.
the quotient of the
First tell me
largest.
Eisenstein criteria. Eisenstein criteria for irreducibility of a polynomial. What is that? Tell me. You told me apply that. First tell me the theorem, right? Then I can help you apply.
Yeah.
What is the theorem? Tell me.
The quotient of the
अरे बाबा आइजेंस्टाइन थ्योरम का स्टेटमेंट क्या बोलता है? Many polynomial fx is irreducible over Q.
P divides.
I have
N.
done already this in class. Basically, I many times use this Eisenstein criteria.
Here not used Eisenstein.
I already used in previous class, right? Did you attend my previous sessions? I have already done these examples. I guess I already done this thing root 2 plus root 3. This is of degree 4 extension basically over Q. So Muthukumar, what is Eisenstein criteria? I already did this in my class.
So there exists a prime number P
Yeah.
which does not divide the highest coefficient.
Okay. And P square does not divide A naught and P divide rest of coefficient, right? This is the theorem.
And P square does not divide A naught.
Yeah, that is the thing. Yeah. Thank you. So this is the problem that you are not joining the previous sessions and then you are coming to last session and basically you are saying this is not done. I already done this. So you can see the recordings basically. These things are already done. So you told me to use Eisenstein criteria. So how I can use? So what is the candidate for P basically? What is the prime I can choose? Tell me.
we can just use 2, sir.
Okay. P is equals to 2 you can use. So P square should not divide A naught. What is A naught? A naught is 1 and P square does not divide 1. And P does not divide 1 basically, right? So you can use Eisenstein criteria. By that one, it is irreducible. How you will prove it is least degree, minimal polynomial? You should prove that this is least degree, right? How you will prove this is least degree? Tell me. How you prove this is the least degree? For proving degree, you need least degree polynomial, right? So how you will prove it is least degree? Ravi Shankar, how you will prove this is least degree? Muthukumar, how you will prove this is least degree?
So the degree is less than or equal to 4.
Yeah, agreed.
Then you construct the towers.
Construct a tower.
Yeah.
Yeah. So what is that tower? The possible degree is 1, 2, and 4. Agreed. That is the tower basically. The 1 is not possible. You can argue that. So how you will discard 2 is not possible?
You construct the tower, we will say Q,
Okay, tell me. Q,
Q root 2
Q root 2.
above
And-
Q of root 2 plus root.
This tower you want to say, right?
Yes.
Yeah, this is the thing. You can argue in this way, but he gave me this computation first. This is the 4-degree extension. Since root 3 is not here, root 2 is not here. So this is, so in this extension, root 2 plus root 3, this is obvious because root 2 is there, root 3 is there. So their sum is there. Here root 3 is not available. So it's over Q root 2. The extension of Q root 2 root 3 will be degree 2. Over here, this is also 2. So this extension is 4-degree extension basically. So degree of root 2 plus root 3 over Q is 2. The another way, but ये तो सबसे आसान तरीका है basically. If you are comfortable with field theory, you can use this tower argument. But if you are not, then you should go in this way. Now we prove already this is the irreducible polynomial, right? So you just need to show it is minimal. So if there exists a minimal polynomial, that what is the meaning of that? That will divide this polynomial. But if that divide this polynomial, then this polynomial cannot be irreducible, right? So I already proved this is a irreducible polynomial. So it should be minimal polynomial. Otherwise, this is a monic also, irreducible also. If there exists a polynomial of degree less than 4, and which root 2 plus root 3 already is a root, then that polynomial also divide this polynomial, right? Agreed or not? That is a contradiction to irreducibility of this polynomial. If you have any doubt, you can ask. Otherwise, I am done in this. Doubts? Baliram, is this clear?
Sir, here how can you use isostem criteria? Here
Why?
the 2 does not divide 1.
1 is
So
A naught basically.
1.
P does not divide A naught, right?
Yes.
What is the Eisenstein criteria? What is the Eisenstein criteria? Tell me.
P does not divide first coefficient, yani highest coefficient, and P divides.
Oh, sorry. P does not divide highest coefficient and P squared. Yeah. Okay, there is some. You cannot use Eisenstein criteria. Agreed. Yeah, sorry, it's my mistake. Someone told me I use Eisenstein criteria, then I go this way. Oh, then arguing in this way is slightly difficult. So how you will prove this is irreducible then? Yeah. Claim that it is irreducible. If you prove this is irreducible, then you are done by the argument I already gave. So how you will prove this is irreducible? So what is the natural way? If you don't have any tool to prove such kind of polynomial, let's assume this is Hx. So if Hx is equals to fx dot gx. If this irreducible, then you can write Hx is equals to fx dot gx, and where fx and gx are polynomials of degree less than 4. So if this is the polynomial of degree less than 4, so then root 2 plus root 3 is either root of fx or either root of gx basically, right? Then since root 2 plus root 3 is root of hx, this implies root 2 plus root 3 is either root of x or gx. So if root 2, okay, root 2 plus root 3. So if root 2 plus root 3 is, so let's, without loss of generality, assume that root 2 plus root 3 is root of. Muthukumar, you can mute yourself. root 2 plus root 3 is root of fx. So basically we can assume that root 2 plus root 3 is root of fx. So this means that degree of root 2 plus root 3 is strictly less than 4 over q. So okay, less than 4 over q. So what you can do from here, so if its degree is strictly less than 4, okay,
Sir, WLOG, what is written over there? The
without
second
loss
last
of
line.
general.
Okay, sir.
So degree of root 2 plus root 3 is, so basically I want to proceed. One is the simple way, right? One is the this way. You can do this tower way. Q root 2, Q root 3. This here 2 degree extension. This is also 2 degree extension, but yeah. Since root 3 is not here and root 2 is not here, so over this Q root 2, this Q root 2 root 3 is 2 degree extension. Since root 3 is not here, so x square minus 3 will be minimal polynomial for this. So this is Q root 2 comma root 3. This is also 2. So this extension will be 4 degree. This is the, so that's why degree of root 2 plus root 3 will must be 4. But what can be other way to prove this? Less than 4 over q. Root 2 plus root 3 is less than, strictly less than 4 over q. Then what is the contradiction? Okay. This means, what is this? This means that if root 2 plus root 3 is in some field k, okay, and what you can say, this is root 2 plus root 3 square should be in k. If some field k, root 2 plus root 3 in k, this means 2 plus 3 plus 2 root 2 root 3 is in k. This implies root 2 root 3 in k. What you can conclude from here? Okay, so this thing, so root 2 root 3 on k. So
Sir,
what you can,
here you use extension.
yeah,
If one is not possible, if one is possible, then it is.
yeah,
belong
one
to
is
this-
obviously not possible. This is not the element of it. I only need to discard 2 possibility, right? But how
Yeah.
we will discard 2 possibility? I know q root 2 over q root 2 root 3 is not there and q root 3 root 2 is not there. But how you will guarantee there is not any other possible? So that needs something to do. So you
Sir,
can for the time
uh,
being you can use this way approach. But another approach, the someone suggests to find this is the minimal polynomial, that is also possible. I did at some point of when I was doing these things, so I done this thing. This is the basically minimal polynomial for this one. You can argue this is the minimal polynomial. I remember exactly. This is the minimal polynomial, but it needs some effort basically to prove this is the minimal. You need to show it is irreducible, and proving something irreducible by explicit computation is not always an easy task. Why one is not possible? One is not the element of field basically. Sorry, this root 2 plus root 3 is not the element of q basically. So if degree of extension is 1 basically, that should be element of q. So this tower method you can adapt. This way you can. Uh, uh, so let's. So let's do this by tower method. So what is the approach? And let's finish out this here. So we will do from here. So by the tower approach, you can approach this problem basically. So root 2 plus root 3 is element of Q root 2 root 3, but since root 3 is not into root 2 and root 2 is not into root 3 basically, so this is the smallest extension containing root 2 and root 3. So basically root 2 plus root 3 is there. So this is the 4-degree extension. So the degree of root 2 plus root 3 must be 4 basically. So in that way you can do, but this is also possible way that the someone suggests, but sorry that we could not complete this approach this time basically. So if you have any idea, you can suggest. Otherwise we can go ahead. Okay. So the last part is saying degree of root 2 plus root 3 over q root 2 is true. This is true basically. Why? By previous argument basically. Over q root 2, what is the minimal polynomial for? What is the argument? Root 2 plus root 3 does not belongs to q root 2. So degree 1 is not possible basically. Why it does not belong to q root 2? If it is belong to q root 2, then root 3 belongs to q root 2, which is not possible. So degree 1 is not possible, but x square minus 3 is minimal polynomial for root 3 over q root 2. This implies root 3 root 2 plus root 3 belongs to q root 2 comma root 3, and its degree is 2. So this is the first question. So any doubt you can ask. So no doubt. So if then we can go to next problem.
Sir, I have one question.
Okay.
I have given in question K be a field.
Okay. So is this doubt related to this problem or some other problem?
No, matlab related to this, what polynomial looks like. Only irreducible polynomial is degree 1 polynomial.
Okay, you can ask me. Okay, ask your doubt. You can ask.
Sir, K be a field such that only irreducible polynomial in Kx are the polynomial of degree 1. What looks like K?
Is there any possible field of that kind? Yeah,
No.
over yeah, means there are some possible field, right? Over algebraically closed field, this is on like over algebraically closed field, every polynomial you can write as a linear factors, right?
Yeah.
So basically these are the only field. Over other fields you can produce higher degree polynomials.
Okay. Thank you.
This is. So K should be algebraic closed for you question.
K is not algebraic closed, then what?
then it is not possible, right? Basically, what is the definition of algebraically closed field? Every polynomial can be written as a linear factor, right?
Yeah.
So if you can write, then that field is obviously algebraically closed. Otherwise, it can't be, right?
Okay.
So the second question. Alpha be a complex number. Suppose that degree, okay, alpha complex number. Suppose the degree of alpha over the field of rational number is m and degree of alpha square is n. Degree of alpha over q is m. Degree of alpha square over q is n. Okay. So these are the four options. First, and always divide m. Second one is n less than m always. Third one is m less than n always. Fourth one is if m is a prime number, then m equals to n. So how you will do this? So degree of alpha over q is m and degree of alpha square over q is n. So what will be greater, right? You know this formula basically. E k f, if this is the extension such that, then degree of e over f is equals to degree of k over f e over k. You know this formula. So what do you think? If a degree of alpha over q is m, then what is degree of alpha over q? Then degree of alpha square over q is n. So it is obvious, right? What will be greater? First one is at least obvious. What will be greater and what will be lesser? F is q in your case, right? K is q alpha. So suppose f is q. This is your smallest field containing alpha, right? Degree is minimal polynomial. If you quotient out by, then this is the degree of extension of this field q alpha over q basically, right? Q alpha square, and this is q alpha, right? Clearly this q alpha, if alpha belongs to right, if alpha belongs to, since alpha belongs to q alpha, then alpha square will always I write this in opposite way. Okay, sorry, what happened? So this is the chain. Here is your q. This sits inside basically q alpha square, and this sits inside q alpha basically, right? Alpha is always alpha square is already in q alpha basically. Alpha belongs to q alpha, so alpha square is already so also in q alpha. So what is the degree of alpha square should be less than degree of alpha basically. So what is degree of alpha square? N, and degree of alpha is m. So n should be less than m. So second one should be true, and you can use for divide this one formula. So what is the formula? Degree of q alpha over q should be equals to degree of q alpha over q alpha square in degree of q alpha square over q, right? So what is this? Q alpha over q alpha square. What is the degree of this extension?
and
Okay, what you need to prove? You need to show that what divide q alpha over q. This is what this you have given, right? Q alpha over q. This is m degree extension basically. This is m. This is n. So what you got? N always divides m, right? This one you got. So n divides m. N always divides m. So first and third are true. If m is a prime number, then m equals to n. This is not true, right? So I give this n always divide m. So if m is a prime number, you can use m is a prime number, then m equals to n. What you can use? M is a prime number basically. So m is a prime number. You can use this is alpha over q. Alpha is equals to √2. You can choose. This is in that case this is a prime number, and alpha square over q is n. Alpha square. So that is 2. That is 1. So in that case, okay. Fourth one you can m less than n. This is always false. If c is true, then b is third one is false. If second one is true, then third one is false since second one is true. And the fourth one, how you will disprove this? You can choose m equals to 2 by choosing alpha equals to √2 basically. Alpha equals to √2, then alpha square equals to 2. This implies n is equals to 1. So m is if m is a prime number, m is equals to 2, and I choose alpha equals to √2, then n is equals to 1. So this implies m does not equals to n. So this one is false, right? So first and second are. Any doubt? Do you have any doubt?
No, sir.
Okay. Let's do next problem. If C is the field of complex number Q, field of rational number, okay, and K equals to Q omega √2. Okay, so this is the interesting problem. C field of complex number, Q field of rational number. Okay, these are the standard notation, and K equals to Q omega and 2 to the power 1 by 3. So this is the third question. K is equals to Q adjoint with omega, comma 2 to the power 1 by 3. Choose all correct statements. For every field homomorphism sigma mapping K to C, we must have sigma K should contain in K. Okay, so sigma mapping K to K, K to C, sorry, sigma K should contain in K. Is this true or not? Tell me. I proved something in my 5th interaction session or 6th interaction session where under field homomorphism where some element can go basically. I proved statements related to that. So whoever attended this session can attempt this question basically. So Baliram, do you have any idea? Baliram.
yes, sir.
So how you will proceed?
Sigma such that K to K. If
For
it is
for every
this is belong Q to Q.
okay, Q to Q basically. Then the statement is that for every field homomorphism, sigma K should contain in K. So how is this true or no? Where under any field homomorphism, omega can go basically. First ask me.
Omega can go to omega, yeah, its inverse.
What is its inverse?
Minus omega.
What is minus omega? Omega is a multiplicative group, not additive group, right? This is the third root of unity.
Yeah, yeah.
So what is omega omega inverse?
Omega squares.
Yeah. So omega can go only either omega or omega square. So where 2 to the power 1 by 3 can go?
2 to the power 1 by 3, yeah, its inverse.
What's its inverse meaning?
2 to the power,
Its inverse is 1 over something, 1 over 2 to the power 1 by 3. What is the meaning of that? Its inverse. सबसे पहले तुमको स्टेटमेंट ही पता नहीं है कि किस स्टेटमेंट के बेस पे तुम ये बोलो. You should know that statement, right?
yes, sir.
Where any element can go under field homomorphism basically.
First is we defined extension on q only, matlab
Q
First-
can go only to Q. This is the
Yeah.
definition of field home. Base can go to base, should go to base basically.
yeah,
Then what? Omega can either go to omega or omega square. Both are present in K. So what
Yeah.
about 2 to the power 1 by 3?
2 to the power 1 ऐसे.
Okay, let me first ask this question. Why omega can go? Okay, you should answer me, right? Why omega can go only to omega or omega square under field homomorphism? You should answer this question. These things I already done in previous sessions basically.
Yes. First defined field homomorphism on matlab
I am direct. I just want to hear a direct statement from you basically. That I already proved in my session. Where under field homomorphism an element can go. Muthu Kumar, can you recall whatever I proved in some session basically? Where a field homomorphism an element can go.
To itself or to its inverse.
No, it can permute just the root of the minimal polynomial basically. The image should be root of same polynomial. I proved this statement in one of my sessions. Agreed or not? If alpha is the root of some polynomial, then phi alpha must be root of the same polynomial. I proved this thing. Can you recall? Okay, if you're not, then maybe you are not revising. Okay, how you will prove this? Okay, the statement is this thing. Suppose phi mapping K to L. These are two field extension of Q. Basically, suppose. Then I am saying that if alpha is root of fx belongs to fx belongs to kx, then phi alpha is also root of fx belongs to lx. So what is the meaning of this? How you will prove this? Fx is equals to, so okay, so fx is equals to alpha is a root of fx. Fx belongs to basically, okay, I will alpha is root of fx. So alpha, fx is a minimal polynomial for alpha. So fx belongs to qx basically. Then phi also, alpha is also root of fx belongs to qx, which is inside lx basically. So what is the thing? So fx is, you can write fx as this thing, right? A naught plus a1x plus an x to the power n. Ai belongs to q. So if you apply any field homomorphism to this thing, so how it will phi of a naught plus, and okay, f of alpha is 0 basically. Alpha is root. So what is the meaning of this? Phi of a1 alpha, you can write this phi of f alpha plus so on phi of an alpha to the power n, and this should be 0. Phi of 0 is 0. So what is this? Phi of a naught plus phi a1 plus dot phi alpha plus so on plus phi an dot phi alpha to the power n is equals to 0. What is this meaning? Phi alpha is also root of fx basically. fx is the polynomial a naught plus a1x plus anx to the power n. So if alpha is the root of fx, since this a naught, okay, what is this thing? I'm in hurry basically. This is a naught basically, since q is fixed under this field homomorphism. This is a1, this is an. So since q is fixed, so this is the same polynomial, right? A naught plus a1x plus anx to the power n. So basically phi alpha is root of the same polynomial fx. So apply this to here, right? So omega where can go? Omega can go to only root of its minimal polynomial basically. What is the minimal polynomial for omega? X square plus x plus 1. You already know this thing. Minimal polynomial for omega. This thing. So this can go only to root of this polynomial, and its root are omega and omega square. That's why this thing omega can go to omega and omega square. Similarly, what is the minimal polynomial for 2 to the power 1 by 3? Tell me.
X cube minus 2.
X cube minus 2 equals to 0. Yeah, x cube minus 2 is a minimal polynomial. So where 2 to the power 1 by 3 can go? Can only go to its root, right? So what are its root basically? Its root are 2 to the power 1 by 3, omega 2 to the power 1 by 3, omega square 2 to the power 1 by 3, right? So all the entries are present in k basically. 2 to the power 1 by 3 is in k, omega 2 to the power 1 by 3 is in k, since omega is in k and 2 to the power 1 by 3 is in k, so their product is also there, and omega square 2 to the power 1 by 3 is in k by same argument. So you can send any entry of k to entries of k only basically under any field homomorphism from k to c basically. So this is the true statement. Okay, so let's write this statement. Okay, maybe this is written some. I proof is correct, but statement seems to me not in an attractive way. So write it in good way. How we will write? Okay, let's write this correctly. That is also correct, but that is not a nice way to write. So alpha belongs to k. Let fx belongs to qx be minimal polynomial for alpha, even minimal polynomial for alpha or any polynomial satisfying which have alpha as a root, then phi alpha is also root of fx belongs to qx. This is correct. Phi alpha. Okay. Phi alpha belongs to L is also root of fx belongs to qx. Yeah, this is the statement. Now it is in a nice way. What happened? Okay. Is this clear or not? This statement is true. For every field homomorphism k to c, sigma of k should contain in k basically. Is this fine or not? Do you have any doubt? Otherwise, I can write explanation explicitly also. But if you are clear, then I'm no need to write this. Basically, I explain you why it is true. Tell me, is this clear or not?
This is clear.
Sir, the first one is sigma of k to
C, complex numbers.
okay.
Is the explanation clear or not?
Yes, sir, got it.
Mayank, is this clear?
Yes, sir.
Muthukumar, is this clear? Okay. So let's move ahead if you have no doubt. So the second part is this: sigma mapping k to k is a field homomorphism such that sigma of cube root 2 is cube root 2, then sigma must be identity. So second part is saying if sigma mapping k to k field homomorphism such that sigma of 2 to the power 1 by 3 is 2 to the power 1 by 3, this implies sigma is identity homomorphism. Is this true or not? It should be obvious for you because I already explained all things in first part. So this should be obvious. Baliram, is this true or not? If not, give me a homomorphism k to k such that sigma 2 to the power 1 by 3 is 2 to the power 1 by 3, but it is not identity homomorphism.
This is not true.
Okay, so give me a homomorphism. This is not identity and satisfies this condition.
Sigma 2 to the power 1 by 3 goes to
Sigma 2 to the power 1 by 3.
goes to 2 to the power 1 by 3, and sigma of omega goes to
Omega goes to,
omega square.
yeah, this is not the identity homomorphism. Agreed? Why it is not identity homomorphism? Since omega does not go to omega basically. And it will give you a homomorphism basically. Q goes to, Q should already go to Q, and what are other, Q should go to, means at Q identity basically, and what are other element? Omega and 2 to the power 1 by 3. Omega goes to omega square, 2 to the power 1 by 3 goes to 2 to the power 1 by 3. So you give the explicitly all full homomorphism basically at all elements, basically all the other element are is linear combinations basically, or multiplication of them. So you give this is the ring homomorphism, but not identity. Not identity. So yeah, whatever this is the false. The third part is saying similar is if sigma mapping k to k such that field homomorphism such that sigma of omega equals to omega, then sigma is identity homomorphism. Is this true or not?
False, sir.
Why?
By similar argument in B section, we can give something that is not an identity homomorphism.
So give me.
Sigma of omega goes to omega,
Sigma of omega goes to omega,
and sigma of 2 power 1 by 3 goes to
sigma of 2 to the power 1 by 3 goes to
omega 2 power 1 by 3.
agreed. So this you can do. So not identity. So false statement. So last one is saying there exists okay, so there are exactly 6 field homomorphism from K to K. There are exactly 6 field some K to K. Is this true or not?
True, sir.
Why?
We got 3 homomorphism from 2 power 1 by 3 to 2 power 1 by 3, 2 power 1 by 3 omega, and 2 power 1 by 3 omega square.
Exactly. Okay. Yeah.
And from
Let's write this homomorphism explicitly basically. Name them sigma 1. What is sigma 1? 2 power 1 by 3 goes to 2 power 1 by 3. Omega goes to omega. What is sigma 2? 2 power 1 by 3 goes to omega 2 to the power 1 by 3. And omega goes to omega. What is sigma 3? 2 power 1 by 3 goes to omega square 2 power 1 by 3. Omega goes to omega. What is sigma 4? 2 power 1 by 3 goes to 2 power 1 by 3. Omega goes to omega square. What is sigma 5? 2 power 1 by 3 goes to omega 2 power 1 by 3. Omega goes to omega square. What is sigma 6? 2 power 1 by 3 goes to omega square 2 to the power 1 by 3. Omega goes to omega square. So this is the explicit description of 6 homomorphisms. So this is the true statement. Yeah. So this is done. So do you have any doubt? Any doubt? If not, then we can go ahead to questions. M comma n comma a comma b denote the arbitrary positive integers. M comma n comma a comma b belongs to z plus. Root a and root b denote the some real nth, okay, nth root and mth root of a comma b. Okay, okay, and then alpha equals to mth root a plus nth root b. Okay, alpha is equals to mth root of a plus nth root of b. If degree alpha denote the degree of alpha over the field of rational numbers, which of the degree alpha equals to degree of alpha over q. So which of the following are true? Which of the following is true? So first part is saying that if n does not equal to m, then degree alpha is mn always. N does not equal to m, degree alpha is equal to mn always. So tell me, is this true or not?
False.
Why? Give me example.
Uh, One second, sir. I used this somewhere for last week assignment, right?
Okay, you can think, right? If n does not equal to m, what are a, b, m, n? You can choose and you can, if this is not true, right? Choose a equals to, okay, root 2.
A is equal to 4.
Okay, what is your, okay, you can, okay, first let's do your way, then I will do my way. A equals to 4,
M is equal to 2.
m is equals to 2. So that means m root a
B is equal
basically,
to 4.
m root a is basically 2 for your case, right?
Yeah.
Yeah, and what is b?
B is same.
4. And what is n?
Nani, B is 9, N is 3.
Is 9 and is 3. And but is n root b. What is this?
Yeah, B is 8. Sir, choose कीजिए 8. 8.
8. So this is 2.
Yeah.
So what? So what is degree of 2 plus 2? Alpha. Yeah, this is correct, right? Alpha is what? Alpha is mth root a plus nth root b. Basically, this is 2 plus 2 is equals to 4. So yeah. So what is degree of alpha? So degree of alpha is basically 1, since this is in Q, and mn is equals to, does not equals to 3.2. So this is false. False. Yeah, this is the example for this. Anyone have any doubt? Okay, if not, then we can go ahead. If degree of alpha, degree of alpha is less than mn always holds. This is saying degree of alpha less than cos mn.
Sir, this degree alpha equal to 1, how did we get?
Okay, what is alpha? What is alpha? Alpha is 4, right? What is minimal polynomial for alpha over q? This is x minus 4. So what is
Yes.
degree of this polynomial? 1. So what is degree of alpha?
1.
So what? So okay. Degree of alpha less than mn always whole. Is this true or not? This should be clear, right? I did for root 2 plus root 3 case. This should be clear from there.
Yes, sir. It should be true. No?
It should be true, sir.
Yeah, by same idea, right? X is equals to, you can write mth root of a plus nth root of b. Then what you can do? You can do x minus mth root of a to the power m plus equals to nth root of b to the power m basically. Then this is just a computation basically. You can open this power mth and then again can remove root term by taking one side and then squaring again, means taking nth power. In same way you can get that this degree. Same computation as x is equals to root 2 plus root 3. So this will be true. So this will be true. You can do this computation. I assume that. I don't want to go there and stuck again there because I don't want to do computation basically. This is easy computation. You can open this mth power and can. So the next option saying is that there exists positive integer m and a b such that degree of alpha is mn. Okay. Tell me, is this true or not? There exists positive integers m and a b such that degree alpha is mn.
True, sir.
Yeah, this one is already true, right? And
Because B is true, so C must also hold.
no, if b is true, then c must not be true, right? This can be strictly less than. You have to give a case, right? M is equals to 2, n is equals to 2, a is equals to 2, a is equals to 2, b is equals to 3. In that case, you know what is degree of alpha. Basically 4. Root 2 plus root 3 का degree ऊपर निकाला था. That's 4, right? So in that case, m dot n basically 2.2, that is 4. Yeah, this is the choice for m and a b. There exists positive integer m and a b such that degree alpha is strictly greater than mn. Degree alpha strictly greater than mn. Is this true or not?
False, sir, because the statement contradicts B.
Yeah.
Which
Degree alpha should be strictly should be less than or equals to mn. We proved this in part B or something there. So what is the next question? Okay, next one is interesting question. It uses some of the cyclotomic polynomial theory. So fifth question. P comma q denote the distinct prime numbers and zeta p zeta q denote the any pth q in qth primitive roots. Okay, zeta p pth. Let me know whatever term you are not familiar, then I can explain you. Do you know pth primitive root of unity? I can explain you otherwise. If you know, then I can directly go to question. What
Sir,
is zeta?
root of unity I know. Primitive root of unity पता नहीं.
Truth of unity basically, right? So what is primitive root of unity? Anyone know? Can answer. What is root of unity basically? Pth root of unity basically. Okay, first ask me. Let me ask this question. What is the pth root of unity? Anyone can answer, right?
Sir,
If
some
it
comp
Roots of polynomial x to the power p minus 1 is equals to 0, right? Okay. So what are primitive root? Basically, this means x to the power p is equals to 1. What are primitive root of unity basically? What is meaning of x to the power p is equals to 1 means x to the power p is equals to e to the power 2k pi I. So that means x is equals to e to the power 2k, k belongs to natural number, union 0, 2k pi I by p, k belongs to 0, 1, 2 up to p minus 1. By same argument, from p onwards, repetition will occur. So we only need to do up to p minus 1. Okay. So x is equals to 2k pi I by p. This is the roots. So what are the primitive roots? You can, the first observation is that pth root of unity form a cyclic group under multiplication. So how you can see? Can you see? All nth root of unity form a cyclic group under multiplication. How you will see? Is this is a group? Is this, can you see or not?
yes, sir, this is a group.
If alpha is a pth root, that means alpha to the power p is 1, and similarly beta is a root, beta to the power p is 1, then alpha beta is to the power p is also 1 basically. Alpha
Yeah.
beta to the power p means alpha to the power p dot beta to the power p, which is 1. Associativity is obvious. What is identity? 1 is already there basically. So 1 is the identity. What is the inverse of an element? If what is the inverse of an element? Okay. Answer me.
Sir, the product is 1, the element and its inverse product is 1.
So what is the that inverse, right? You have to answer.
1 by omega, if omega is there.
Okay. Okay. So if omega to the power p is 1, you are saying what is 1 by omega? That means if omega omega will be obviously non-zero. So 1 by omega to the power p is also 1. So 1 by omega makes sense, right? So 1 by omega is also pth root of unity, and this is the inverse for this one basically. Yeah, fine. So this forms a group. Why it is cyclic basically? I give you generator. This zeta p is equals to e to the power 2 pi I by p. This is the generator basically, right? 2 pi I to the power p1, 2 pi I to the power p2, 2 pi I p to the power 3, basically varying. This is giving all its generator, all the possible values of x, right? Agreed
Yes,
or
sir.
not?
Yes, sir. Degree of zeta is equal to the degree of group.
Yeah. Degree of zeta is equals to? What is degree of group means?
That the elements of group, number of elements of group is equal to degree of zeta.
मतलब हाँ, मतलब बेसिकली जीटा की पावर से तुम सारे के सारे रूट्स ला सकते हो
Yes,
बेसिकली,
sir.
बोलना
Yes,
चाहते
sir.
हो. Agreed or not?
Yes.
agreed, sir.
Yeah. So that this is the generator of the cycling. कुछ फील आ रहा है क्या? साइक्लिक ग्रुप में तुमने पढ़ा है बेसिकली ऑल साइड, मतलब Zn are cyclic group basically. So this group are basically isomorphic to Zn. And what is the explicitly isomorphism is that Z mod, what is the Zn से इसमें एक isomorphism दे सकते हो तुम basically. Let me denote this group by mu n. Group all of all nth root of unity. So any element here a, here you can send this to power this primitive root, whatever I choose it, I write zeta. Yeah, 2 pi I to the power p, basically zeta n, you can write it zeta n to the power a. You can check that this is an isomorphism. Group isomorphism. Yeah, these two groups are isomorphic basically. So this is the generator of this cyclic groups are basically the primitive root of unity. So this is the primitive root of unity. Generators of the cyclic group mu n are primitive, are called nth primitive root of unity, right? So these are the nth primitive root of unity. So what are the generator of the cyclic group Zn? Basically elements co-prime to n, right? You know this theorem, right? Anyone can respond.
Yes, sir. Phi n.
Yeah, basically number of generator is fine and there are elements which are co-prime to n. In similar way, what are the generator of the group mu n? Basically this choices, zeta n to the power a co-prime to n basically, where zeta n is 2 pi I by n, e to the power 2 pi I by n. And so all such will be generated since it's isomorphism, and you can prove this basically. These are the easy statement. You can refer to Damit food books for this thing. Maybe, yeah, these are easy exercise you can do on your own. So since time is also about to over, so let me complete this quickly. So these are the primitive roots definitions. So if zeta p is a primitive root of unity and zeta q is a primitive root of unity, if p less than q, then zeta p belongs to q zeta q. So the first statement is saying if p less than q, then zeta p belongs to q of zeta q. Q zeta q means splitting field of this one, this cyclotomic qth cyclotomic polynomial basically. Qth cyclotomic polynomial is x to the power q minus 1. Its splitting field is called q zeta q. So is this true or not? If p less than q, then zeta p belongs to q zeta q. Is this true or not? Tell me, is this true or not?
Yes, it is then. सर पी और क्यू को प्राइम जैसा कुछ होगा क्या, मतलब सेम से ट्रू?
P और q distinct prime numbers. Distinct
हाँ
prime
सर,
numbers.
ट्रू होना चाहिए.
क्यों ट्रू होना चाहिए भाई? नहीं होगा ट्रू, क्यों होगा true? सी, ये दोनों साइक्लिक ग्रुप हैं. जीटा पी एक ग्रुप म्यू पी का एलिमेंट है बेसिकली. एक तो वे यही है सोचने का. जीटा पी किसी ग्रुप क्यू पी का एलिमेंट है, ये किसी ग्रुप म्यू क्यू का एलिमेंट है, और पी और क्यू कोई दो डिस्टिंक्ट प्राइम नंबर है. ये पी ऑर्डर का एलिमेंट है और ये क्यू ऑर्डर का एलिमेंट है.
ओके यस सर, तब तो नहीं होगा.
मतलब दिस इज नॉट द करेक्ट वे टू अंडरस्टैंड, बट या इंट्यूटिवली तो यही से सोचना चाहिए बेसिकली. बट rigorous ways need some more things, right? P less than q, then zeta p belongs to q zeta q. P strictly less than q होना चाहिए बेसिकली. इक्वल के केस में तो strictly less than होगा. So how you will do this? If p is strictly less than q, then zeta p belongs to q zeta q. If this is false statement, how you will prove? P equals to 3, then zeta p is equals to omega. Take q equals to 5. Q equals to 5. Yeah, you can take q equals to 2, right? Q equals to 2. Then what is zeta q? What is second primitive root of unity? -1. Then this implies zeta p does not belong to q minus 1, which is q basically, right? Agreed
Yes.
or not?
Here P is greater than Q.
Oh, p P is okay. P is good. Okay, we need P strictly. So take Q is equals to 5 basically. Okay, improve this one. Improve this one. Take Q equals to 5. Take Q equals to 5. So what are fifth primitive root of unity basically? These are of the form x equals to e to the power 2 k pi I by 5, k equals to 0, 1, 2, 3, 4. So you can check explicitly their value since time is also over, and you can see this omega value is -1 plus minus iota root 3 by 2, and prove that omega does not belongs to this q fifth zeta 5 basically. This implies the statement is false. I want to do this cyclotomic polynomial complete theory today, but I couldn't since you asked me to do these problems of assignment. But this is an interesting theory you can learn on your own. Maybe this is the last assignment, last interaction session, or maybe we will get one after. When is your exam for this course?
Next Sunday, sir, 26th.
Okay, so maybe, so that means this is the last session for this course. So I hope you all enjoyed this session. So with this, I will stop. And if you want to say,
So the
Sir,
last
please
one, sir, -1 plus minus I root 3 by 2.
okay.